All right. Sorry I'm not with you today. I am home with my sick daughter, but we're going to try and get you through the notes and through the criterion B. So this video is going to be all about the notes. Vertical angles and linear pair are two types of angles that we've already studied. If we look at this diagram and we're looking for those vertical angles, we could pick 4 and 2, 1 and 3, 9, 11, 10, 12, 5, 8, or 7 and 6. This just says we need two examples, so I'm going to say angle 1 and angle 3, and angle 4 and angle 2. A linear pair, we're looking for adjacent and supplementary. So we've got 1, 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10, 11 and 12, any of those, also 9 and 12, 10, 11, 1 and 4, 2 and 3, 6 and 8, 5 and 7, all of those would work. Again, it just says to pick two. I'm gonna go with the ones down here and we'll call it 9, 10, and 11, 12. Angle 9, angle 10, angle 11, and angle 12. All right, so that's kind of a review of those vertex angle relationships. Again, those are called vertex angle relationships because the angles share a common vertex. That's that corner of the angle. A transversal is a line that intersects two or more coplanar lines. I think I checked yours. I hope it came out a little bit nicer, but anyways. So in this diagram right here, we've got line C is our transversal of line A and B. It's nice colorful on my copy. I don't think it's so colorful on your copy. No, it's not. So now we're going to talk about some relationships in this transversal picture. So the first one is interior angles. Interior angles are in between the two lines A and B, like this. Interior is inside those lines. The transversal is the line that crosses the two lines. So interior is inside the line. So for this, I'm gonna write inside A and B. And I'm sorry, I'm gonna have to let my dog out. Give me one moment. Oh, there's no good way to do this, sorry. All right, so I was better at video editing. I'll make that go away. Here we are, exterior angles. So again, talking about the lines A and B, exterior is going to be outside of those lines. So outside A and B. Then we've got alternate interior angles. So when we talk about alternate or same side, that case we're talking about the transversal. So alternate of the transversal would be like 1 and 8. And since it's asking for alternate interior, we're going to talk about 3 and 6. So those are on opposite sides of the transversal and inside of A and B. So we can talk about angle 3 and angle 6, or angle 4 and angle 5. And those are the only two sets of alternate interior angles in this picture. Alternate exterior angles, now we're going to go outside of A and B. 1 and 8 and 2 and 7. Angle 1 and angle 8, or angle 2 and angle 7. All right. Again, those are the only two sets of alternate exterior angles. Same side interior and same side exterior. Now we're talking about the same side of the transversal. So 4 and 6, or 3 and 5. Angle 4 and angle 6, or angle 3 and angle 5. And those are on the same side and the same side of the transversal inside of A and B. Then same side exterior, are going to be 2 and 8, or 1 and 7. Angle 2, angle 8, or angle, let's see, 1 and 7. All right. And again, those are on the same side in the exterior. Corresponding is the only one that the name doesn't directly apply, right? So alternate interior, alternate exterior, same side interior, same side exterior. Those really line up with exactly what you expect. Corresponding is going to be in the same location in relative to the vertex. So for instance, one, I would call one the top left, because if you go from the vertex, it's above the vertex and on the left side. So angle 5 is above and on the left. So I'm going to label that one top left. So 1 and 5 correspond. So angle 1 and angle 5 correspond. And we have 4 sets of corresponding angles. So I'm just going to run through those real fast. Angle 2 and angle 6. Angle 3 and angle 7. And angle 4 and angle 8. So you can see, again, with 2, it's above and on the right. 6 is above and on the right. Yeah, you can go get a stuffy. See, she really is at home. Bottom left is 3, bottom left is 7, bottom right is 4, bottom right is 8. And so you can see that they're in the same relative location, and that's why they're called that corresponding angles. Transversal mania. All right, so this is an activity that I want you guys to try. I'm just realizing that this might have all printed out on the wrong page. I'm sorry. Anyways, whatever picture you have here, I copied it yesterday, so I know there's a picture here on yours, is the picture that you're going to use. And you're going to write down how many transversals are present. And again, that's going to be 1, 2, 3, or 4. The transversal is the one that crossed 2 lines, at least 2 lines. And you're going to answer some questions about that picture. And then we're going to pick a team, and you are going to tell me which type of angle you think will occur most often when you use a random number generator. Just Google random number generator, limit it to 1 to 12, make sure it's showing just natural numbers, just the integers there from 1 to 12, and then record the 2 numbers that the random number generator generates. And you're going to name whether those angles are vertex angles. They share a vertex. So think about that first kind of idea that we were talking about. Or whether it's transversal angles. So there are 2 angles that share a transversal. And then what is the named angle relationship? Be careful, there might be some that don't have a named angle relationship. For example, if we look at 3 and 8, 3 and 8 are transversal angles, but 3 is on the inside, 8 is on the outside. 3 is on the left, 8 is on the right. There's no named angle relationship for that, and that's okay. So it's okay to put none for angle relationship. Also, this activity here, not the most vital thing you're going to do today. I really want you to understand the name of these transversal and vertex angle relationships. And that's what's going to take you into the criterion B, which I'll make another video for because I got to let my dog back in.